Okay, this video is about joins in Spark. But first let's start with the dataset we're going to be practice on in this exercise. The main entity of dataset is product. It's about some kind of a food selling network. And here we have various products which are some kind of goods you can find in a grocery store or something. For example, all-season salt is a type of product. Okay, product has two attributes which are separate entities, aisle ID and department ID. Aisle is a general type of goods, for example, specialty cheese or instant foods or an energy granular bars. So that this is an attribute of product and it's a type of product. Okay, department is another attribute of the product, and it's frozen, produce, alcohol, bakery. So it's general category of the products. Okay, then we have orders of these products. Orders have user ID, order number, etc. Order, the entity order in this dataset is basically invoice header or invoice. Something which groups a number of items. Now we have order products prior entity, which is the fact of including specific product into the specific order. So we have product ID, we have add to cart order, which is line number, and not sure what reorder it means. Maybe it's ordered the second time or something. This is another order product strain. This was data science dataset, so this was so the one of them is train data and another is test data. Though this has less attributes. So this, which is called train, is something you should probably predict something. But it's not very important for us for exercise on Spark. We're not going to be doing data science. We're going to be joining, grouping, selecting these things. So these entities are predefined as variables in the notebook, and we are going to use them. We're going to make joins between them and various other things. Okay, these are possible joins between them. For example, aisle can be joined on product as left, or product can be joined on aisle as inner. Doesn't matter. Department can be joined on products. Products can be joined on aisles and on departments. Orders prior can be joined on orders. Orders trains can be joined on orders. Orders prior can be joined to products. Train products can be joined to products. And orders prior can be joined to products full, which is product joined with two other entities, and the same with train can be joined with product full. These are counts, and here we can see the count of everything we've got here: product, aisles, etc. So we have 32 million orders and 1 million plus orders trained, which we can experiment with. So this is something they look like. We will skip it. Okay, let's start with the exercise. So this is the first exercise. We need to inner join products with alias. So it's basically simple join on small amount of data, and I actually did it with 8 possible ways. So the simplest way is you write products join alias on ILID how inner. This can be written even simpler by removing named parameters, but this is somehow we can see it. And this is the result. alias ID, product name, department ID, IL. Department is not important, but we have product and its IL. So chocolate sandwich cookies and cookies cakes. These are this is the IL of this product. All season salt belongs to spices seasoning. Robust, golden, and sweetened oolong tea belongs to teas. Smart ones, classic flavored mini something belongs to frozen meals, and green chili sauce belongs to marinades mean preparation. So basically, one belongs to this. This product belongs to this aisle, to this category of food. And as you can see, all 8 methods of joining produced the same result. So let's see how various, what are the various way you can write simple inner join in Spark. Okay, this is the shortest way how we write it. This is the same, but I specified the list of fields to be produced. This can be placed in a different order, or it can be placed with different aliases. Okay, this is almost the same, but you can see the field name is in brackets. It's a list. So on can contain more than one field, but if you join on one field and put it inside list, it produces the same result as one element. Okay, this is the longer way of writing. You specify first entity dot key and another entity dot key. One of them is foreign key, another of them is primary key. So IL ID is a primary key and products IL ID is a foreign key. Again, select with names. Next thing. This is the same as the previous one, but the fields are addressed or taken in a different way. We have brackets and the field names. They are taken in an index style way. And also in the same thing in select. I have taken fields in an index style way. Okay, this is another type of writing the same join. As you can see here, the entities are aliased. They are assigned short alias names. As going forward, the same will be done in the straightforward query. So products aliased as P, alias aliased as A, and here in on we have expression. In inside expression we use alias A dot ILID, P dot ILID or point. No. As you can see, we have single equal sign here because this is a SQL style expression. Here we have double equal sign because this is Python style comparison. You see, in previous examples I used double equal sign. Okay, these first examples where we have on and single field, they presume that fields are called the same way in both tables, so in products ID and in aisles ID. However, if they are called differently, you should use this notation or this notation or this notation. In terms of speed, it doesn't much matter, so I will do experiment to see if it's true. Okay, next thing. Here in select, I also used expression, and I used alias before the field. And as you can see, I can place alias and call it something else. So I called it the same way. Here in some other examples below, I will be renaming them. Okay, this was the sixth type of writing inner join. Now we have two more types, and these are queries, like outright SQL queries, Spark SQL, but to use products and aisles in Spark SQL, we need to create or replace temp view, and then we can use them in the query. So to use them here, you have to declare them as temp views. And using of aliases is at your discretion inside the query. So this is the classic inner join with on first field, second thing. And this is the last one. This is the same type of Spark SQL. It also expects these temp views, but instead of ID equals ID, we can put using. This is a syntax possible in Spark SQL, and it is equivalent to the very first example where we have placed simply on. It expects that both keys in both tables have the same name. Otherwise, you have to specify equal comparison and give the exact expression. Again, all 8 methods produced the same result. Okay, next we're going to do left join. We have to left join products with departments. So each product has department, but let's check if some products have no department. Basically, on expects that fields are called the same way in both tables. Then we have select, and you can see these are the fields we have selected. Okay, I checked if there is anything where department is null, and no null departments were found. Now, this is here I do the same thing using expression. I declared aliases, I declared second alias, and I wrote equal expression. See, here I wrote expression which uses as P department ID as products department ID, D department ID, departments department ID. This is different notation than this one, but both notations produce the same result. You can finish this expression and write dot alias and this name. Actually, I do it in the next somewhere below. Again, same result, only names are different now. You see, instead of department ID, product ID, products department ID, and departments department ID. They are the same. I was looking to find out if they have left join. Okay, product name, LID department, all the same. Again, no null departments, so no instances where nothing was null at the right side of the join. But here here is actually another way of writing it. This is another method of aliasing, so you can write department ID, and then alias this way. It produces the same result as here. So here we wrote expression with S. Here we have wrote without any expression with using alias syntax. Okay, here is another attempt at the same thing, but I actually tried to produce left join with empty right side. I added this fake expression, so we are adding only those departments which are even, which modulo 2 equals 0. And here if we finally get a situation where department at the left is some specific ID and department at the right is null. And you can see all the numbers are odd. And where the numbers are even, we have match. So this first selects unmatched, and the second select matched situation of left join. So here we have both IDs, here we have only one ID, and the right side is null. So this demonstrates that this was in fact left join. Okay, right join. Right join is not frequently used, but we can actually use it. Okay, I had to rerun the code, and here we see the result. So we have right joined IOS on products, and everything was matched because products ID is not null everywhere. Null products IDs are not found. Okay, but I then did the same trick. I only joined the even IDs, and as we can see, those which are even are joined product file ID. Yes, evens are joined and odds are not joined. So odds have nulls. Else nulls. So this was a right join in action. Okay, let's go further. Here is another example of the same thing, and we can see both null and not null situation for the IELTS. Here is the same thing done with the query. Right join on IDs equals and selecting only events, and again this is not matched and these are matched. Okay, next scene, full join products and IELTS. The same thing, but it's a full join. Full join is called outer, not full but outer. So it can match left side to right side. Here I did the even word way. IELTS are modulo 2 and products are modulo 3. This is to emulate the both sides of join. So here we have product on the right side, here we have IELTS on the left side, and here we have both of them. I have emulated it by this expression. And the next, I have decided to look at the execution plan. And here we have execution plan in formatted way. There are other ways of displaying plan. And we can see it scanned CSV files. It made some kind of projection, exchange, sorted two things, sort, merge, join, and make another projection, and finally join them. My understanding, this is not optimal execution plan. It shuffles among nodes of whatever we have here. Here are more details on each step. In memory data file, read schema, and so on. Hash partitioning. I will do more experiments on plans in further videos. Okay, left semi-join. So left semi-join should do left join, but so if the product appears in op prior, it will return only those products. So we are doing products on prior, and we will obtain only those products which are found at the right side. And actually, without any weird manipulations, we have found that 11 products were never ordered. No, never ordered by or prior. So they have, these are examples of this product. You see, a product might have many matches in the right table. But here we are dealing only with those which did not match. So there's a products count, and these are matched products count, and these are not matched products count. And we are displaying opt prior yes, we are displaying products count minus X count. So this were not ordered. This were ordered. This is a total amount of products which were ordered, and this were not ordered. And this is the total amount of opt prior. Actually, I wanted to say this, that despite the fact that it might have several rows to be attached, it only selects one row per product. It doesn't select product repeatedly for all those matched. This is how left semi-join work. So again, product could have been sold 10 times and could be mentioned 10 times in opt prior, but this join includes only one line for each product. No many, how many times it has matches in the second table. That's the point. Okay. Here I actually demonstrate this thing. You see, semi-join result set contains product ID only one time, only one row for product ID. And this is opt prior, where product ID equals 5. And as you can see, we have multiple product IDs equals 5. So these were multiple rows, but it only included one time in the result of left semi-join. Okay, now I did the same query as in the previous, no, almost the same, but with left join. And left join actually joins right fields. Oh, semi-join only has taken fields from product, but left join has taken both products and prior. And as a result, we have multiple lines on those which are left joined. Actually, here I have filter where product ID is null, and where product ID is null at the right, it will, you see, opt prior product ID is null, whereas product ID is not null. Yes, this is, you see, this is the product ID from products, and this is the product ID from op prior. And you see, this one is a number and this one is a null. There is one line for each because this is null. Okay, left anti-join. Here we actually are trying to select those 11 products which were not joined. So basically this one was calculating those which were joined, you see, and by subtracting I have found the amount of those not joined. And here left anti-join should produce these 11 products right away. And I did it in a number of ways. Also, I have experimented with broadcast. So this is a simple way of doing it. So we have 11 products, and here they are. There are only 5, but if I continue, there will be 11 elements. So a left anti-join means please find those which do not have matches. So those products which do not have matches, that's right. Here is the equivalent way of doing it. We collect products which exist in prior, and I filter those which are not in exist. So this is achieving the same result by not in query. Now I did it with broadcasts, which broadcast products across multiple nodes, which is a subject of timing, but broadcast didn't change the result. It might have changed speed. Okay, here I am doing the same thing with direct queries. You see, where product not in, it's the same approach. This is how you can write broadcast with the query hint, and here is doing it with what is called left anti-join. So we are doing left join and then checking product is null. This is the same thing with broadcast hint. This is the same thing with not exist way of writing query, and this is not exist with broadcast. I have prepared this for speed testing, but I will do this in another video. The end result is the same. 11 products are selected. Multi-column join. Okay, now we get to the real business. There are two conditions in the join. ID by ID and plus some other condition. You can write this with expression, you can write it with direct query. I won't spend much time on it. Conditional order, only join orders prior with order do equals 3. Okay, again, double condition on. inner join, and here also inner join. Next thing, left join with a special type of selecting. Join and select left data frame in a single column. Basically, the exercise asks us to select all columns from products. You can use star in index-like pane, and you can select a single field from alias. That's how you do it. Okay, broadcast join. So we have already did it. I didn't even write on here because it has somehow found. No, this is wrong. I will fix it now. Okay, I had fixed it and put else here. Now it's have joined correctly. Next scene, join orders with their trained products. So orders, order ID on train order ID, type inner, and select only 3 fields. So inner join and 3 fields selected, simple thing. Okay, these are 2 joins, products on aisles and then on departments, and then select some specific fields. So this is the first join expression, this is the second join expression. Okay, join on transformed columns. So this exercise asks us to rename columns or create calculated column and join on calculated column. So I have taken orders, added column. Basically I have taken order ID, converted it to string, and added aliases required to write this expression, and did the same thing here. Basically this is some kind of subquery which is assigned alias, and thus we can do this. So, and it has, you know, this order ID, and so on. Okay, cross join, generate a Cartesian product between 2 very small data frames, else first 3 rows, multiple departments, 3 rows. Okay, it asks us to take 3 rows and then do all permutations between them. So we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and so on. Here is, we have it 3 by 3 combination. This is written by cross join, and this is written by join of the type cross, how cross. The result is the same. So you can use cross join, or you can use join how cross. Okay, join using aliases. We have done this above, products else on expression with aliases, single equal sign, because this is SQL style code. Okay, I'll inner joined. Join orders plus opt prior plus products. No, this is a simple double join. Orders prior on this, and then on products on this. You see, opt product on products. You can select actually. Product is contained in this table. It's not contained in orders. But you can select anything field from anything used above. Here we have select list of what we were expected to select. As you can see, this is the first table, this is the second table, this is the third table. Okay, we have 3 fields. Anti-join to detect users without any trained orders. Okay. I have here experimented with raw number to deduplicate users but here is what we do. We have orders on order trains with left anti-join. Okay, again, there is no separate entity users. Therefore, we collect users from orders. User can exist in multiple orders. Therefore, I deduplicate it. So I do left anti-join. I found those orders which do not contain corresponding op train. Then I run a window function which uses deduplicate. This is the same syntax here. So I use row number partition by user ID, order by order ID. So I am taking the user from the first order. So if we have multiple orders for the same user, I am taking the row number 1, which is the first order ID. And here you see left anti-join can be written directly in the query. And row number actually executes after left anti-join. First the join happens, then row number is calculated on what has been produced by this from and left anti-join. And we have the same result by both queries. So the queries did the same thing. They have this query created a row number by Spark code style, window, and frame. So this is function, window function. This is a window. Window consists of partition by and order by, and here is partition by, order by, and filter by 1, and here I dropped a row number and ordered by user ID. So the results are the same, except we can't drop a row in the query. Actually, we can try to experiment one thing. Oh, you see, I got it. You have run query, which is written by pure SQL, and then you can drop column from that query. So whatever I did here, I also did here. And users are in the same sequence. So as you can see, now we have the same result with the only thing that removing unnecessary column can only be done by Spark, or you have to specify the list of fields directly in the query. Okay, here we have another example which is not hard to understand. We join orders on orders prior and filter those which have specific condition. I believe we can take fields from both tables. This evaluates to SQL expression. The only comment, if you have fields named the same way in both tables, then we have to introduce aliases and use them here in expression to distinguish between two tables. Okay, this is double join, product aisles and then departments, nothing special, 3 fields selected. And here full outer join, we have outer join on order ID, and here we have right side not matched, and we don't have situation where left side was not matched. Now finally I decided to experiment with select expressions. So orders obtained with aliases, and as you can see, you can write expressions in expression function. But here is another type of writing it. It's select expression. You can write expressions directly without specifying expression each time. So you do it by comma separated list. Okay, and this produces the same result. Okay, that was enough about joins and some syntax. In the next video I will be covering group by and aggregations.